Okay, differential equations. We're going to do the back side of the note sheet. Number 5. The first thing we have to do is separate the variables. So this dx has to move over to the right. So we are going to multiply both sides by dx. So dx over 1 here and dx over 1 here. So these are going to cancel out. We have dy on the left, and on the right we have 2y dx all over x. Now we need to move this term right here, the term with the y. 2y needs to move over. So now we are going to divide both sides by 2y. Alright, so these are going to cancel. I am left with dy over 2y. Now I'm going to rewrite this. There's a 1 out front here. Okay, so I'm going to rewrite this part right here. Okay, so we're going to rewrite that, and we're going to pull that apart. And it's going to look like this. We're going to pull out the 1/2 times 1 over y dy. So that is what we're going to do. Because when we integrate that side, this will come along for the ride, and we know the antiderivative of this. So again, if you multiply across the top and across the bottom, this expression here is equivalent to this. All right, on the right-hand side, we have dx over x. I'm going to rewrite that kind of the same way. There's a 1 out front of this dx, so I'm going to pull out the 1 over x right here, and it's going to look like this. 1 over x dx. All right, so make sure you go through that step, how to pull these apart. And here's why, because the next step is to integrate both sides. And now when we pull those apart like we did, we know what to do with everything. Okay, some of you are going to be able to do that just by looking at it. Some of you will need a couple steps, whatever you need. But the first step is to separate the variables and rewrite each side so that you will be able to take the antiderivatives. Okay, so let's go up here. On the left, again, 1/2 comes along for the ride. The notation is going to drop out, the elongated s and the dy. The only thing that we're taking the antiderivative of is 1 over y, and the antiderivative of 1 over y is ln absolute value of y. All right, on the right, same thing. The elongated s and the dx are going to drop out when we take the antiderivative. The only thing that we're taking the antiderivative of is 1 over x. And the antiderivative of 1 over x is ln absolute value of x. And don't forget plus c on the right side. Okay, now we have to get rid of 2 things over here. We have to get rid of the 1/2, and we have to get rid of the ln. Now down the road, to get rid of this ln, we can exponentiate. But before we can exponentiate by making e the base, we have to get rid of this 1/2. So the first thing we're going to do is we are going to multiply this side by 2, and we are going to multiply this side by 2. So on the left, we are going to see that these are going to cancel out. We have ln all by itself there, ln absolute value of y. On the right, we are going to distribute that 2. So we are going to get 2 ln absolute value of x plus 2c. This is still our constant here. All right, now we can exponentiate both sides. All right, so if you remember, we make e the base. Okay, that is called exponentiating. Now, we do that because on the left, the e and the ln are right next to each other. They cancel each other out. We are left with the absolute value of y. Absolute value of y is left on the left side. Now, right here, our c is in the exponent. So now we rewrite this whole side using exponents. So it looks like this. We have e to the 2 ln absolute value of x times e to the 2c. Okay, now this is representing our constant. That is our c, because e is a number 2.718. 2 is a number. If you take this to this, you end up with a constant. So that is our C. We can call that our C. All right, so now we have the absolute value of y is equal to, and the absolute value of y is just y. So I'm going to try to, actually I'll go off to the side here so you can see it. So the absolute value of y is just y. Now what I can do with this term right here, I'm going to highlight it in yellow. Okay, I'm going to rewrite that term using exponents. Okay, so check it out. I'm going to draw a little line so you can kind of see what I'm doing. But I'm going to take this 2 and I'm going to make it be the exponent. So it's going to look like this. We are going to have e to the ln, absolute value of x, but then we are going to take that and we're going to square it. So we're going to take this 2 and we're going to put it out here. This is equivalent to this because when I'm raising one power to another, I multiply and get this. Okay, and let's bring this down. So then times c. What this allows us to do is this e and ln are right next to each other. Those are going to cancel out. All right, so then our final answer is going to be y is equal to the absolute value of x squared times c, and then I can put that constant out front, and the absolute value of x is just x, c times x squared. So that is as far as I need to go. Now that is a tricky problem. There's a lot of steps there. So please try to go through that on your own, and there'll be more like it. All right, 6 is a different type of problem that we see when we're dealing with differential equations. It's giving us a solution to a differential equation. Now, differential equations have multiple solutions. So we're going to start by kind of working backwards. So what we're going to do is we're going to try to prove that this right here, I'm going to highlight it, this is the solution to this differential equation. So what we're going to do is we're going to take this and we're going to plug it into this. This is our equation. But now if you notice, we have to not only plug in y, we have to plug in y prime. So the first thing we have to do is find y prime. So I'm going to come down here, and I know that y is equal to x minus x to the negative 1. I'm just bringing this down here because that can help me find y prime. To find y prime, we just take the derivative. The derivative of x is 1. When we take the derivative of negative x to the negative 1, that's the derivative power rule. Negative 1 times negative 1 is positive, and then if we subtract 1 from the exponent, negative 1 minus 1 gives us negative 2. So this is what y is equal to. This is what y prime is equal to. Now we plug this in for y. I'm going to highlight this in green now. Okay, this is what we're going to plug in for y right here. All right, and then I'm going to use yellow. I'm going to plug in y prime. I'm going to plug that in right here. Okay, so now let's try it. We're going to rewrite this. Okay, now I like to rewrite it and use blank set of parentheses. X times y prime plus y is equal to 2x. So I just took this and I rewrote it, but instead of y prime, I put in a blank set of parentheses, and instead of y, I put in a blank set of parentheses. Now I plug in y prime right here. So y prime is equal to 1 plus x to the negative 2. That goes right here. 1 plus x to the negative 2. And then I'm going to plug in y right here. Y is equal to this, so I'm going to plug that in right here. X minus x to the negative 1. So again, I took this equation and I plugged in y, which was given to us, and I plugged in y prime, which I found by taking the derivative of y. Now we simplify and see if the left equals the right. So the first thing we're going to do is we're going to distribute here. Okay, so x times 1 gives us x. All right. Now, this is x to the first right here. When I distribute here, x to the first times x to the negative 2, when you're multiplying exponents that have the same base, you add the exponents. So 1 plus a negative 2 gives us x to the negative 1. All right, again, x to the first times x to the negative 2 gives us x to the negative 1. Because when we are multiplying two exponents, 1 and negative 2, that have the same base x, we add. Now we keep going, the plus comes down, and I have this whole thing just comes down. So I have x minus x to the negative 1 is equal to 2x. All right, that's an x there. Okay, so now let's add like terms over here. All right, the first thing that we notice is that, hey, we have a positive x to the negative 1 and we have a negative x to the negative 1. Those cancel out. Now we have an x, and that, of course, gives us 2x, and 2x is equal to 2x. So we just proved that this right here is a solution to this differential equation. Okay, let's do another one. Exact same thing. Over here, we are given the solution. Y is equal to negative 2. That is a solution. And we are going to plug it into this equation. Now, if you notice, we not only have to plug in y, we have to plug in y prime, the first derivative, and we have to plug in y double prime, the second derivative. So we're going to take this over here, y is equal to e to the negative t, and we're not only going to find y prime, we are going to find y double prime. We're going to find the first derivative and the second derivative. Okay, to take the first derivative, this is a chain rule. The outer function is e, the inner function is negative t, and I'll write that out if it helps. The outer function is e to something, the inner function is negative t. So the derivative of the outer is e to something, the inner as is negative t, and the derivative of the inner is negative 1. So I put that out front. So the first derivative is negative e to the negative t. And now I go again. I take the derivative of this. And that still is going to be a chain rule. The negative 1 comes along for the ride. So negative, the derivative of the outer is e to something. The inner as is negative t. The derivative of this is negative 1. And negative 1 times a negative 1 is going to give us a positive out front. So this is y prime, this is y double prime. If you notice, y and y double prime are exactly the same. Now we take these three things and we plug them in up here. So I'm going to rewrite this equation. And I'm going to use blank set of parentheses. So y double prime plus 2 times y prime plus y is equal to 0. So I just took this equation and rewrote it and put a blank set of parentheses. Y double prime plus 2 y prime blank set of parentheses plus y blank set of parentheses. Now I plug in. Right here is y double prime. I'm going to plug in this. So that becomes, right here, e to the negative t. Now here, after the 2, I'm going to plug in y prime. So that's right here. That goes here. Negative e to the negative t. And then last but not least, y goes right here, and y is right here. Right here is e to the negative t. All right, now let's just simplify. This comes down, e to the negative t. Here we have a positive and a negative, so that's going to be negative right here. So we have negative 2e to the negative t, and then this comes down, plus e to the negative t. All right, now we add like terms. Our like terms are here. We have, oops, I need a highlighter here, sorry. we have an e to the negative t and another e to the negative t. So if I have an e to the negative t and you have an e to the negative t, that gives us 2, highlighter again, excuse me, that gives us 2e to the negative t. All right, and then we bring this one down, so we have minus 2e to the negative t is equal to 0, and this right here is equal to 0, so 0 is equal to 0. So this indeed was a solution to this differential equation. So problem 6 is just another type of problem that we see when we're dealing with differential equations. You're given a solution and you plug it in and see if it works. Okay, the last thing we're going to do is we're going to solve this differential equation by separating and integrating, and then we're going to come over here and we're going to use that to find slopes. Okay, so over here, let's separate and integrate. So the dx moves over to the right, so we multiply by dx over 1. So these cancel. I have dy is equal to negative 0.36 x dx all over y. Now the y needs to move over. The y is in the denominator, so we're going to multiply both sides by y. Y over 1 here and y here. So we end up with y dy on the left. On the right, these cancel, and I'm left with negative 0.36 x dx. So my variables are separated. Now we integrate. So we put the big elongated s in front, and we take the antiderivative of each side. The antiderivative of y here is 1/2 y squared. On the right, the antiderivative of negative 0.36x, the negative 0.36 comes along for the ride. And the antiderivative of x is, of course, x to the second over 2 plus c. And now we just simplify the right side, 1/2 y squared. When we divide out right here, negative 0.36 divided by 2 gives me, of course, negative 0.18 x squared plus c. So there is our differential equation. Again, you only have to get the term with y in it by itself. There's no ln here, so that's as far as you need to go. Okay, now let's finish this up. We can also use a differential equation to find the slope. If you remember, the slope, you guys, is the same as the derivative, all right, which is the same as y prime, which is the same as dy dx. So let's focus on this, all right, and let's go over here to this differential equation right over here. So let me get rid of the work from the last problem so we can see it. Okay, right here. This, okay, this right here, oh, highlighter, come on. Okay, this right here, dy dx, is representing the slope. Our slope is equal to this. So if I have an xy point, I can plug it in and find dy dx, the derivative, the slope. All right, so that's all you have to do for 7b. Okay, so let me get rid of my mess here. Let me bring over that differential equation from the right-hand side. So the differential equation was dy dx, our slope, is equal to negative 0.36 x over y. So that was our original differential equation. Now we plug in our point. This is my x and this is my y. So I'm going to rewrite this equation. Dy dx is equal to negative 0.36 times my x, which is 5, all over my y, which is 2. So I just plug in my x here and my y here. So now we just bring down dy dx, my derivative, my slope, and I simplify this. I just multiply negative 0.36 times 5, and I divide it by 2. This times this divided by this will give me my slope at this point. So my slope is negative 0.9. All right, that is my slope. My slope is equal to negative 0.9. Okay, one more. We take this point and plug it in. All right, so we take our differential equation that was given to us in part A, the original one, not after we separate and integrate it. We want to keep dy dx there when we're asked to find the slope, negative 0.36x times y. So now this comes down, dy dx, and we plug in our x on top. Our x is negative 8 this time, and my y is 0. Okay, now, hey, I can't divide by 0, so that is going to give me an undefined slope. All right, so that is our slope is undefined. All right, can't divide by 0. Okay, this is tricky stuff. We're going to spend all next week working on these, so it will get better. We will keep going through this. Thanks, calculus.